Dear students, let's go ahead with the next numerical. Here we are going to be solving two numericals based on simple beams. The question for the same is same for both the diagrams. Determine the support reactions of the beam loaded and supported as shown in figure. Now here we see that there is a beam. The beam is horizontal, having a length of overall 6 meters. It has a moment of 50 kilonewton meter clockwise as well as a value of 20 kilonewton meter anti-clockwise. At point A we have a hinge support, while as at point B we have a roller support. Before we go ahead, we have to draw the free body diagram of the question which is mentioned to us. So let's draw the free body diagram. So you draw the beam as it is, you show the loading as it is. Since this is moment kilonewton meter, as well as you have the other moment, that is 20 kilonewton meter. At point B we have a roller support, so you will have one vertical reaction, so that will be vertical at point B. At point A you have a hinge support, so you will have one vertical, that is vertical at point B, as well as one horizontal reaction, that will be horizontal at point vertical at point A and horizontal at point A. Now since now we have drawn the free body diagram, we can now go ahead and calculate the unknown values, which are nothing but the support reactions. Let us use the two equations. We have an equation, summation forces in x direction equal to 0, summation forces in y direction equal to 0, and summation moment about any one point is equal to 0. We have three equations and we have three unknowns, so we can use the three equations to calculate the three unknowns. If we take summation f of y first, we will get two unknowns, that is VA and VB. Therefore it is beneficial that we first use either the equation of x and then the equation of moment, finally equation of y, to calculate the three unknowns. So taking summation forces in x direction equal to 0, we have one force, that is HA, and there is no other force acting in the x direction, so HA directly turns out to be 0. This is one of the unknown reactions. Now let's take summation moment about point A is equal to 0. This is the equation. We have to now apply the values into it. So HA and VA both will not appear in the moment equation since they are passing through point A. The remaining all will appear. So 50 is a clockwise moment. You take it as 50. We do not have to multiply it by any distance since it is already a moment. A 20 kilonewton meter moment is an anti-clockwise moment, so that will come out to be positive. We have VB into the entire distance, that is 6. This will go in an anti-clockwise direction, therefore that will be equal to positive, and this will be equal to 0. This gives us the value of VB as 5 kilonewton. So we have the value of VB now. Let's use the third equation, that is summation forces in y direction equal to 0. In this particular question we notice that there is no vertical force that is acting against VA and VB. Therefore VA has to actually be totally opposite to VB. So they both will be opposite in sign. This is what we can see. Let us calculate the same and check whether what we are getting is correct. So VA going upwards, we put it as positive. VB going upwards, we put it as positive. There is no other force in the vertical direction, so equal to 0. This gives us that VB is nothing but minus times VA, and similarly VA is nothing but minus times VB. So we get the value of VA as minus 5 kilonewton. Using the three equations, this is how we calculate the three unknowns. Now let's go to the next numerical. In this next numerical we have been given a trapezoidal loading at one end and a uniformly distributed loading at the other end. So what we can do now is we can go ahead and now check that this trapezoidal loading, instead of taking it as a trapezoidal loading, we'll take it as a rectangle and as a triangular loading. Here we don't have to take two separate rectangles. what we can do is we can take the rectangular loading till the end. So this will become one rectangular loading and a triangular loading. Okay, now when we are doing that, we have to calculate the point load, equivalent point load. So by how will we do that? So as previously mentioned, we will take the loading as length into breadth, since it is a rectangle. So the length mentioned over here is 5 meters, that is the complete length. Into the breadth is going to be the intensity of the loading. So the intensity of the loading here is 2 kilonewton per meter. Meter gets cancelled and we have a loading of 10 kilonewton point load, which is an equivalent loading which will act at the center of the beam. So this will be a 10 kilonewton loading. We have to note that since it is acting at the center of the beam, therefore the distance gets divided into 2 and you have a 2.5 meter distance from one end and similarly a 2.5 distance from the other end. So this is how the distance gets divided since the loading is acting at the center. Secondly, what we are going to do is we are going to try to calculate the loading for the triangular load. So we take the support of the reaction for area, where we are replacing the height by the intensity. So that is half into base. So the base of the triangle is 3 meters and the height, the entire overall height was 4, but we have removed the 2 kilonewton from that. Therefore the pending height will be 2 kilonewton. So this is 2 kilonewton per meter. We have a 3 meter span. Meter gets cancelled, 2 gets cancelled. So we have a 3 kilonewton loading. This 3 kilonewton loading is going to act at 1/3 from the perpendicular side. So this 1/3 from the base. So from this perpendicular side we are going to have a loading over here. This loading is going to be nothing but 3 kilonewton. Now this loading is going to be at a distance of 1/3 from the base. The base was given as 3 meters. Therefore this distance will be 1 meter, which is nothing but 3 meters and 1/3 of 3 meters. So that is equal to 1 meter. Okay, now since we have already converted the loadings, let us also convert the support reactions. Here what we have is known as a fixed support. Since it is a fixed support, we have already seen in the previous video that it will be replaced by 3 unknowns. What are the 3 unknowns? So you will have 3 different support reactions. The support reactions will be one vertical, so that will be vertical at C. Then you will get it as one horizontal, so that will be horizontal at C. Now we see that this entire loading is going to try to move the beam in a anti-clockwise manner. Therefore we have to give a support in the opposite direction to keep the beam stationary. Therefore we give a clockwise moment, that is moment about point C. We have to understand that all these 3 unknowns, VC, HC and MC, are all 3 unknown values and we have to calculate the value of this. In this you will notice that all the 3 equations are independent of each other. Therefore you can use any of the 3 equations, summation x, summation y, summation moment, at different instances to calculate the values of the equation. Let us go ahead and now calculate the equation. First, summation forces in x direction. Since there are no forces that are going to be against HC, so we will get the value of HC directly equal to 0. This does not happen in every case. In case there is any inclined loading that is given, then you will always get a reaction from the other side. Okay, let's go ahead with calculation of summation forces in y direction equal to 0. Now in this, VC is acting upward, so it is positive. 10 is acting downward, therefore it is negative. 3 is acting downward, therefore it is negative. And the summation of all will be equal to 0. Therefore we get the value of VC as 13 kilonewton. So this is the value of VC. Now let us apply the moment equation. So summation moment about point C is equal to 0. Here what I am doing is I am taking a moment about point C. This is an equation, and we are now replacing the values of the different values that are given from the question into this particular equation. So what are the different forces? We have a 10 kilonewton force, a 3 kilonewton force, and we have this existing moment. This moment is about point C, and therefore MC does not be equal to 0. In fact, we have to calculate the value of MC. So let's take, so that will be 10 into 2.5, the distance. That will go anti-clockwise. Anti-clockwise is positive. Then we take the next force, that is 3 kilonewton into that distance, that will be 1 meter. That will again go anti-clockwise, so that is positive. MC on the other hand is acting clockwise, so that will be negative. MC, there is no other force or moment, therefore we equate this entire thing to 0. Now what we get as the final answer is moment about point C is equal to 28 kilonewton meter. This is how we calculate the different reactions using the 3 equations of equilibrium.